The expected value or mathematical expression is the average value of a random variable over a large number of experiments. I will explain all you need to know about it in the next 5 minutes. If there is a share worth $100 at this moment, and you know there is a 30% chance it will worth $120 next month, 30% chance remain the same, and 30% chance down to $70. In this case, we know all the probabilities, but how can you decide whether this share was buying or not? The expected value can be used to answer this question. For this example, we need to know the expected value of the anticipated gain or loss for that investment in 1 month's time. In statistics and probability analysis, the expected value is calculated by multiplying each of possible outcomes by the likelihood each outcome will occur and then summing all of those values. Let's find out the expected perfect value of our example. See, although there's more chance this share will go up next month, the expected value is negative, which indicates you shouldn't buy it. Now let's see an example of using expected value to make a strategy. In basketball, different points are awarded to players based on where they are when they shoot the ball. Behind the 3-point line will award 3 points, and inside the 3-point line only award 2 points. However, the shooting average will be getting lower if the player is far away from the basket. Since the ultimate object of basketball is to score more points, let's find out how by calculating the expected value. Say one player's chance of score behind the 3-point line is 40%. Inside the 3-point line is 50%. And slam dunk is 60%. Then the expected value of each score type is This means over the long term, each time shooting behind the 3-point line or slam dunk will lead to 1.2 points, while shooting from inside the 3-point line will only get 1 point. From our analysis, this player should try to shoot less inside the 3-point line in order to score more efficiently. I believe now you get the idea that the expected value is useful to examine the random variable's long-term value. Speaking of long-term, you probably remember the law of large numbers, which convert the observed frequency to probability. It is a bridge connects randomness to certainty. Further, the expected value converts the probability to a certain number, which enables us to do the analysis. To make the expected value work, we have to assign a value to each result, like the score point in the basketball example. Have you ever wondered how to balance the character's skill in a computer game? They are all different, but no one is too strong or weak. Easy. The game designer assigns a number to the character's each aspect, such as attack damage and defense, and then calculate the expected value. All characters should have a similar expected value. If the character is too strong, lower the attack damage a little bit, or if it's too weak, adjust its defense a little higher. Assigning a value is not always as easy as for the game characters. You must know the old saying that one man's trash is another man's treasure. Most of the time, there's no objective value. For example, if you ask me to play a game, toss a dice, 1 point I will get $1, 2 points I will get $2, and so on. The game will take me about 30 seconds. The expected value is $3.5. Will I play it? If I'm waiting for a bus and looking to do something to kill the time, at that moment 30 seconds was almost zero for me, so I will say yes. But if I'm working on an urgent project and really need to make every second count, in that case, 30 seconds was much more than $3.5, so I would say no to that offer. 3 takeaways. First, the expected value is the average value of a random variable over long term. It quantifies the variable, which gives us an indicator of whether it's worth doing or not. Second, in order to calculate the expected value, we have to assign a value to the random variable. Third, most of the time, there is no objective value for a random variable. For the same variable, we may assign a different value during different situations. I'm always here at your service. See you in the next one.